Hi guys, welcome to today's video. Today we're going to talk about combinational circuits and sequential circuits. The content, the digital circuits, the combinational circuits, the sequential circuits, the application with the real world examples, and its conclusion. Introduction to digital circuits. Hmm. Definition of digital circuits. Digital circuits are circuits that operate using digital signals which represent discrete values, zeros and ones. These circuits are designed to perform a specific logical or arithmetic operation. Importance of digital circuits in electronics. Digital circuits form the foundation of modern electronics. They are widely used in various electronic such as computers, smartphones, and telecommunication systems. Digital circuits enable the efficient data processing, storage, and transmission. Digital circuits can be divided into two types: combination circuits and sequential circuits. Combination circuits are circuits where the output depends solely on the current input. The output is determined by the combination of logic gates and their interconnections. Sequential circuits are circuits where the output not only depends on the current input but also on the previous input history. These circuits have memory elements and utilize feedback to store and process information over time. Combination circuits provide instant output without any memory element, while sequential circuits have a memory elements and provide outputs based on both current and past inputs. Sequential circuits can store and process data, making them suitable for complex computations. Characteristics of combinational circuits. Combinational circuits are digital circuits where the output is solely determined by the current input values. The output is obtained through a combination of logic gates and their connections. Combinational circuits have no memory element. The output depends only on the input values at a given instant. The output changes immediately with any input change. The basic building blocks of combinational circuits. Logic gates are fundamental building blocks of combinational circuits. They perform basic logic operations such as AND, OR, and NOT. Truth tables are used to describe the behavior of logic circuits and combinational circuits. They represent all possible input combinations and their corresponding output values. Boolean algebra is a mathematical system used to analyze and design combinational circuits. It defines logical operations and provides rules for simplification and optimization. Combination circuit design process. The design process involves identifying the required input-output relationship, selecting suitable logic gates, creating a truth table, simplifying the logical expressions using Boolean algebra, and implementing the circuit using chosen logic gates. Examples of combination circuit design include adders, multiplexers, subtractors, and decoders. These circuits perform various arithmetic and logical operations. Understanding sequential circuits. Explanation of sequential circuits. Sequential circuits are digital circuits where the output not only depends on the current input but also the output depends on the history of the past. These circuits utilize memory elements to store and process information over time. Properties of sequential circuits. Sequential circuits have memory elements to store information. The output depends on both current and post inputs. The output changes based on the clock signal or the feedback. Flip-flops. Flip-flops are memory elements used in sequential circuits. They can store bit of information and change states based on the clock signal. Shift registers. Shift registers are cascaded flip-flops used for storing and shifting binary data. They can be used for parallel in serial out (PISO) or serial in parallel out (STIPO) operations. Counters. Counters are sequential circuits that generate a sequence of binary numbers. They can be synchronous or asynchronous. Sequential circuit design process. The design process involves defining the required input-output relationship, specifying the number of memory elements, creating a state transition diagram, implementing the circuit using flip-flops and logic gates, and testing the circuit for correctness. Examples of sequential circuit design include finite state machines, shift registers, and counters. These circuits are used in various applications such as digital clocks and communication systems. The tools and techniques required for circuit analysis. Simulation software. Simulation software allows the analysis and testing of digital circuits by simulating their behavior. It helps in verifying correctness and identifying potential in issues. Timing analysis. Timing analysis is a process of evaluating various timing parameters of digital circuits. It ensures the circuit meets the required time construction. Verification method for digital circuits. Formal verification. Formal verification uses mathematical techniques to prove that a digital circuit meets its design specification. It ensures that the circuit behaves correctly for all possible inputs. Testing techniques. Testing techniques involve applying input stimuli to the circuit and checking the output for correctness. It includes function testing, boundary testing, and fault injection methods. Error detection and correction. Parity check. Parity check is an error detection method that involves adding an extra bit of information to the transmitted data. The receiver will detect whether any errors have occurred during transmission. Error correction codes. Error correction codes are used to correct errors in the transmission set. They provide redundancy that enables the receiver to reconstruct the original data even with so many errors. Digital systems and electronics. Digital processes. Digital processes such as microcontrollers and CPUs are extensively used combination and sequential circuits for executing instructions and performing arithmetic and logical operations. Memory systems. Memory systems including RAM and ROM simply and employ combination and sequential circuits for data storage, retrieval, and addressing. Communication systems. Data encoding and decoding. Communication systems rely on combination circuits for encoding data into signals suitable for transmission and decoding received signals back into the original data. Modulation demodulation techniques. Modulation and demodulation techniques used in wireless communication utilize sequential circuits for converting digital data to analog signals and vice versa. Emerging technologies in digital circuit design, quantum computing. Quantum computing is an emerging technology that utilizes quantum qubits to perform computations. It has the potential to revolutionize digital circuit design and enable faster and more efficient processing. Reconfigurable computing. Reconfigurable computing focuses on designing the circuit on the basis of whether they could be reprogrammed or reconfigured to adapt to different computation tasks. This flexibility allows optimization and customization of circuits for specific applications. Challenges and opportunities in digital circuit design. Power consumption efficiency. Reducing power consumption and improving overall efficiency are major challenges in digital circuit design. Techniques such as low power design and energy efficient algorithms are being developed. Integration and miniaturization. Advancements in semiconductor technology enables increased integration and miniaturization of digital circuits. This leads to higher performance, smaller devices, and more complex functionality. And that brings us to the end of the video, guys. Thank you for watching.